Then I invite Professor Suani to come over and get started her lecture. Aqui em cima.
Hi, good morning, bom dia, bonjour, buenos dias, what else? Guten Morgen, buongiorno, that's it. This is the best I can do. Okay, so here we are again, second day on bioenergy. And so yesterday we had very nice presentations from Professor Kinoshita from Hawaii, Professor Cortez from Unicamp, very nice discussions. And today, as we had showed yesterday, we are going to have two very important speakers, Professor Eric Larson from Princeton University, the famous one, and Professor José Luis Silveira from Unesp, the Vice Director of the Bioenergy Program at Unesp. And also, more or less the same way we did yesterday, I'm going to give you a brief overview. Based on our discussions from yesterday and from our several questions and people interested in some more details, I did some updated in my introductory session, trying to answer a few questions. But anyhow, I will leave some time. I did a brief introduction, and then I will leave some time so we can have discussions and answering some questions about that. So we are going to talk a little bit about bioeconomy and bioenergy sustainability, and then we will have the main lectures. As we have discussed yesterday, the main issue related to bioenergy is that biomass can be used for several end uses, not only energy, but food, animal feed, chemicals, materials, and energy, of course. As we saw yesterday, the difference of this modern biomass and the traditional biomass is sustainability and efficiency. As we saw yesterday, when you use traditional biomass, we have huge losses and a few energy really being consumed for cooking and heating. When we go for modern bioenergy, we have very lower losses and more efficient process. But because we have all these others end uses, it's important to discuss the sustainability, and also it's a new area of research, bioeconomy. So bioeconomy is now being seen as an interesting option to diversify local production, and a very important issue for developing countries. I was participating in a recent workshop in Copenhagen during the European Bioenergy Conference, and there was a small side event about bioeconomy in different countries. And it was a very nice discussion on the perspectives of a bioeconomy. In fact, it's a new area. A lot of it still has to be done, but perspectives are very interesting, mainly because we can put together sustainability and development. We can add some value, a lot of value in rural areas because of the biomass production. And then we can, of course, put together bioeconomy and sustainable development. A few examples of what we could do, and it have been discussed here. For instance, when we have biomass, and mainly organic matter, traditionally we do anaerobic digestion to produce biogas, to produce electricity or heat, but we can also upgrade this biogas to produce biomethane and reforming biomethane, we can have methanol and fuels. So some examples of new uses of biomass. For instance, here in this study, we have a mapping of European Union showing the residues available in the region. So we can use these residues for different uses in the context of bioeconomy. Here we can see the potential of agricultural residues worldwide. We can see the huge amount of possible residues in Asia and also in South America and North America, mainly from the crop plantations. You see here sugarcane bagasse, mainly in South America, in the case of Brazil. You see here rice straw in Asia from rice production. Here in Brazil, our bioenergy group has been developing in the recent past the Atlas of Bioenergy, which is funded by the Ministry of Mining and Energy, which shows the potentials of bioenergy produced from residues. For instance, electricity in sugar alcohol sector or biogas from different sources. You can find it in our site at internet. I showed you yesterday. More recently, from this Atlas of Bioenergy, several states in Brazil have used the same methodology to do their own state atlas. So, Alagoas, Rio Grande do Sul, Pernambuco, and here what is Espírito Santo, they have used the same methodology we developed to do their potential of bioenergy from residues. And now, more recently, we have just started to do it for São Paulo State. It's a joint project with SPSASRE, which is a local utility in São Paulo, and then we are doing the Atlas of Bioenergy for São Paulo State. And one of the most important issues, of course, is the potential from the sugar alcohol sector. As you can see here, this is the state of São Paulo. We have this dot black point are the sugar mills in the state of São Paulo. And then we have a huge potential. We already have a lot of energy produced from them. I'm going to show you. But anyhow, we still have a huge potential, mainly when we think about biogas from vinasse. I'm going to talk about that. Here you have the different areas from the gas utilities, Gás Brasiliano, Comgás, and Gás Fenosa. Here you have the gas pipeline bringing the natural gas from Bolivia. And then we have a huge potential of producing biogas and biomethane from the sugar mills and to inject it in the grid. We discussed a little bit about it yesterday. And specifically in the case of bioeconomy in Brazil, I showed you this slide yesterday just to remember. One of course, the most important is the ethanol production. Just to give you some figures I showed you yesterday, we produce 29 billion liters per year in Brazil, a sales price around $1 per liter. Now a little less than this because dollar exchange rate increased, so it would be a little bit less. But anyhow, we would have like 29 billion US dollars per year, which is quite an amount when we compare with Brazilian GDP of 1 trillion US dollars last year. I also would like to share with you a recent study on bioeconomy published by CEPAL and then discussing bioeconomy in Latin America, discussing exactly sustainable transformation of biological resources including waste generated in the processes, and then trying to see what are the perspectives in Latin American countries. In this presentation, I'm skipping it, but there is also some references to local countries in Latin America. Argentina, Paraguay, Mexico, Uruguay, and you can have a look on it. Okay, so we started to discuss a little bit about bioenergy sustainability yesterday. Many questions here in the audience. We had the opportunity to discuss that. So I'm going to show you some figures on bioenergy sustainability. And of course, we always try to make it related to the Sustainable Development Goals. At FAO, the Food and Agriculture Organization in Rome from the United Nations, there are several groups working on bioenergy sustainability, the GBEP, Global Bioenergy Partnership, and now they are also working on sustainability indicators and also trying to put together sustainability indicators for bioenergy and the Sustainable Development Goals. So later on, if you are interested, we can discuss a little bit more about that. So according to IEA bioenergy in the bioenergy technology roadmap, it's important to relate bioenergy and sustainable development because we can reduce, as you saw yesterday, greenhouse gas emissions, to improve energy security because we can diversify the energy supply and also reduce the fluctuating global energy market. It's always important to remember that when we talk about fossil fuels, there is an inequality in fossil fuel production worldwide. We have petroleum production concentrated in some countries, mainly in some regions. And then it's sometimes very difficult for developing countries to get this supply. Even when some developing countries have their local oil production, many times they don't have the products from the oil. For instance, Nigeria is a country where we have oil production, but there are no refineries. So the country has to export the oil and then to import the oil derivative. So this issue of oil imports is always a challenge for our developing countries. Another issue very important is the economic opportunities, including jobs and income for rural economies. Because we improve rural areas, we have to produce the bioenergy and the residues, and then we have a lot of new jobs creation. And this, of course, is always important for developing countries. We can complement efforts to improve waste management and air and water quality, and we are going to talk about it today. There is a strong synergy between bioenergy from residues and the sanitation, basic sanitation, which is always a problem in developing countries. And last but not least, it helps to improve modern energy access for some of the almost 3 billion people who lack it, as we discussed it yesterday. So when we talk about job creations, you can see from RAIN 21 that bioenergy has a lot of jobs, mainly in rural areas, you see here, compared with other renewables. And then because we have to produce the biomass. Sorry. Here in Brazil, We have some studies, recent studies, talking about the development and the influence and the impact of the ethanol from sugarcane and the impact in the municipality. So this is a recent publication funded by FAPESP and developed by colleagues from the Agricultural School in Piracicaba, showing how the growth of sugarcane in Brazilian municipalities have a positive impact on the municipal gross domestic product per capita. The main results of this project dealing with the effect of sugarcane growth in the municipalities in the state of São Paulo shows that there was a 10 percentage points increase in the relation sugarcane area temporary crops, and then a municipal GDP increases $76 per capita. The industrial plant installation also increases the average municipal GDP, like more than 1,000 US dollars in the municipality where the mills is installed, and almost more than 400 in each of the 15 municipalities around the mill. And considering timeline, 10 years after the mill installation in the sugarcane areas, the annual municipal GDP increased also more than $1,000 in the municipality where the mill is installed, and more than 300 US dollars in each of the 15 municipalities around the mill. So even, probably you don't know, but here, Ribeirão Preto, which is the region where sugarcane started and we have lots of mills, is called the Brazilian California because it's considered the most developed region in the state of São Paulo. Going for other issues related to sustainability, Professor Kinoshita showed it yesterday, when we talk about energy balance, which is the amount of energy produced from that crop divided by the fossil fuel consumption in the production. And here you can see the comparison of the sugarcane ethanol with other sources like wheat, sugar beets, and corn. And you see that sugarcane ethanol is much higher energy balance. And I usually to say, to remember that this is not because, as we say in Brazil, we usually to say God is Brazilian. And more recently, with Pope Francis came here in Rio, he said, we had, I don't know if you follow it, he said, we have a very good agreement because God is Brazilian and the Pope is from Argentina. So, and then we used to say that, oh, it doesn't matter how many problems we have in Brazil, God is Brazilian, we are going to solve it. So we are optimistic. But anyhow, I used to say that this is not because God is Brazilian, but this is because we don't use fossil fuel to supply our industrial needs. The thermal and electricity needs in the plants, in the mills, are supplied by the sugarcane bagasse. This does not happen with wheat, sugar beets, and corn because they use fossil fuels, natural gas or coal. And that's why the energy balance is lower compared with sugarcane bagasse. And because of this, when you see the avoided carbon emissions with gasoline replaced by ethanol, then you see that sugarcane, sorry, I just realized it's in Portuguese, but anyhow, you see that sugarcane, you have avoided emission of almost 90%. These are figures from EPA from the United States. And when you see other ethanol sources like corn and wheat, sugar beets, and cassava, you have lower avoided emissions. And here you have second generation ethanol, lignocellulosic residues, and even the existing studies show a lower carbon emissions avoided compared to sugarcane. Also, a consequence of the good energy balancing, you can see here, these are figures from IRENA, the International Renewable Energy Agency. You can see the production costs of ethanol. Here you can see sugarcane, ethanol, corn ethanol, and then other wheat, like in Europe. So you see that, in fact, the average production cost of ethanol is much lower when it's produced from sugarcane compared with the other sources. Here you have more detailed figures. Of course, you see, like as Cortez said yesterday, like an electrocardiogram, so you can have ups and downs. But anyhow, we have an average important small cost, production cost. Here we have some historical figures updated recently by Professor Goldenberg and one of our students, Patricia, showing that, you see here, we have 75, beginning of the alcohol program 40 years ago, and then you see ethanol much higher than gasoline. And then when we increased the ethanol production, we had an important decrease. This is what we call the learning curve. So you see that more recently we have lower and lower. Of course, recently we had a small increase here because of several local problems that we had with ethanol production in Brazil. But you can see we have an important trend of reduction in production costs in Brazil. And this is an important experience that we always like to share with other developing countries, because in many times local governments in these developing countries are worried about the production costs, because sometimes the initial evaluation of production costs are very high, and many times the local governments are worried about, oh, but it's too high price, it's higher than gasoline, and what we should do. And then I think this Brazilian experience is important to show that when we increase the production, and we always have an important reduction cost. This happened with other renewable energy, as you are seeing here, like photovoltaic and wind energy. As Cortez showed yesterday, we have most of our sugarcane production in center-south, which means Midwest, Center-West, and Southeast. You see here figures from one of the recent harvesting seasons. You have a small, we have a small amount produced in North and Northeast, more or less 40 million tons of cane, mainly to produce sugar, to export, because here we are nearby other countries in North. And then most of it, more than 600 million tons of cane, produced in Center-South. And then in these areas, there is no irrigation. All this cane is rain-fed. We only have irrigation and fertilization with vinasse, which is a byproduct from ethanol production. So let's talk a little bit about water. People in general, it's a matter of concern. Water consumption, water quality, and then let's talk a little bit about that. Let's talk about water quantity, water consumption, how it's now in sugarcane sector, how is the efficiency, how we are doing progress in this water consumption, and then water quality. And then we are going to talk a little bit about water quality, and also not only sugarcane, but also the synergies of water quality and the basic sanitation. Here you can see some figures. In the 90s, the consumption in the industrial phase, because I just said that the agricultural phase is rain-fed, so there is no fresh water being catched, so it's rain-fed. So you can see that in the 90s, we had around 5 cubic meters per ton of sugarcane. And now we have some mills with less than 0.7 and more recently 0.6, 0.5. So almost 10 times less. You can see the reduction, 5, less than 2, more than 1, less than 1. Now the regulatory environmental agency of São Paulo established 0.85. And we have some mills with 0.7 and more recently 0.6, 0.5. Mainly because of water recycling and also higher efficiency in the water treatment. And another issue very important is that we don't have to wash sugarcane anymore, because we are going to see it. Our sugarcane is not anymore burned. It's green harvested with machines. So we don't have the manual harvesting. We don't have to burn the sugarcane. So it's much cleaner, the sugarcane. So it arrives in the mill, and it's not the need for cleaning is not that much. And when it is necessary, it's cleaned with air. So the cane is not washed anymore. And another issue that also make this reduction to happen is that now the industries have to pay for water. In the past, the water was for free. They could catch from the river, from underground water for free. Now they have to pay for it. We have a regulatory agency, and this regulatory agency establishes the payment. And of course, when you have these economic issues, this is always an important issue. So you can see the trend. So the reduction of the water catchment, the use in the industrial phase. And these are figures from UNICA. We have goals that we should reach 1 cubic meter per ton of cane in all mills. We have it in some mills, but the idea is to have it in all mills. You see here some mills below 0.7. Sorry. So again, talking about the agricultural phase, as I said, most of the sugarcane in Brazil is no irrigate, just rain-fed. We have a recent assessment by ANA. ANA is the regulatory agency for water in Brazil. It's a federal agency. They did this recent assessment based on georeference mapping, and then they concluded that almost 99% of sugarcane crops is fair to irrigate with vinasse. And there is no water discharge. Remember, vinasse is this byproduct from ethanol distillation, produced in very large quantities, from 8 to 12 liters of vinasse per liter of ethanol. And then it's used for fair irrigation. Besides that, we are going to talk about that, there is a new trend to use it in a more efficient way, to do vinasse biodigestion for energy production, and then together the fair irrigation. Here you can see vinasse being transported by pipelines and being distributed in sugarcane fields for irrigation and fertilization, because vinasse has a very high organic content, so this is very much important for fertilization in sugarcane fields. About that, we should comment two things. First, vinasse has a very high potassium content. So, of course, if the soil has already too much potassium, you cannot use vinasse. This is what happens, for instance, in north of Argentina. The region of Tucumán, where they have sugarcane plantations, because it's quite north of Argentina, it's more tropical. The soil in Tucumán has already a lot of potassium, so there the vinasse cannot be used for fertirrigation. Okay, so they are working for this other use, like vinasse biodigestion. Okay, another issue is that it's always important to have an adequate environmental legislation. In Brazil, we learned a lot about that. Remember that the alcohol program started 40 years ago for economic reasons, just to replace oil imports, because Brazil was going to bankrupt. By that time, nobody cared about environmental. Climate change, nobody knew about that. So during these 40 years, we have learned how to make it more and more sustainable. As we saw, for instance, water consumption was reduced. And also in other aspects, because in the beginning, vinasse, by that time, was just discharged in rivers, killing fishes and with lots of environmental impacts. Then we started having environmental legislation. It was forbidden to discharge in rivers. Mills had fines, have to pay fines if they did that. And then they realized that they could use it for fertirrigation. So they started using for fertirrigation. The same happened in the pulp and paper sector. In the very, very past, black liquor, a byproduct of pulp production, was discharged in rivers, also killing fishes and environment with lots of environmental impacts. Then environmental legislation forbidden it. And then they realized that they could do it for energy. And now we have in Brazil a huge installed capacity of electricity from black liquor in pulp industries. Another example, more recently, in Rio Grande do Sul, the rice industries had always a lot of residues. The rice husks, they also usually discharged it in an inadequate way. Then environmental agencies starting to put fines, and the industries have to pay for it. So they started having to put the residues in landfills and to pay for it to put in landfills. And then what they did, they discovered they could burn it in boilers and to use it for energy. And the example of Rio Grande do Sul has spread it all over the country. We have a huge amount of installed capacity of electricity from rice husks in Brazil. They developed special boilers because rice husk has a lot of silica content. So we had a lot of technological advances when we have a good environmental legislation. Coming back to vinasse, more recently, since we have the vinasse used for fertirrigation, the Environmental Agency of São Paulo State started also to control the amount of vinasse which was used for this irrigation because of the underground water, for not having contamination of underground water. So all mills in the state of São Paulo have to fulfill these requirements of the environmental agency controlling the amount of vinasse discharged in the fields. So here you have, this is the legislation for vinasse applications. It's in Portuguese, sorry, but this is the control. They establish the requirement for the disposal of vinasse. And then more recently, we are having a new trend, the use of vinasse for biodigestion process and then producing energy, electricity. Here you can see a new plant in the state of Paraná. Paraná is one of the important sugarcane producers in Brazil. And then you can see Geoenergética. They have a new plant doing the biodigestion of vinasse together with filter cake, another byproduct of the process, tops and leaves. They have now a 4 megawatt installed plant with the expansion for 16 megawatts. And we have new perspectives here in the state of São Paulo. Raízen is building also a new biodigestion plant for vinasse to produce 20 megawatts of electricity. Talking a little bit about biogas, it's important to remember that biogas is not only can be produced from vinasse, but also from different organic matters. We have biogas from landfills. We can have biogas in sewage stations. We have biogas from rural and animal residues. We can have biogas from agro-industries. In fact, this is not yet a reality in Brazil. We have a few experience. We have still a lot to do. I'm going to show you. But we believe that the perspectives are very much important. That's why we are sharing this, because this is important for other developing countries. For instance, in the state of São Paulo, here you have some scenarios. The region of Sertãozinho, nearby Ribeirão Preto, where we have a huge sugar cane production. The scenarios that we have show that we could produce around more than 300,000 cubic meters of biomethane per year. And if we build a gas pipeline of around 40 kilometers to make the interlink of the mills with the gas pipeline, we could supply biomethane for this gas pipeline. This is not happening yet. These are scenarios for the region. We still do not have any mill supplying biomethane to the gas pipeline. We have biomethane, which is the biogas cleaning product. We have biomethane in Rio from landfills. We have biomethane in northeast of Brazil, in Fortaleza, from landfills, being injected in the natural gas grid. But not yet from vinasse, despite the fact that it's the biggest potential that we have. Another important issue is that, as we discussed here, our energy balance could be better, still higher, if we had not the diesel consumption. Even the carbon emissions avoided is not 100%, because, of course, there are other issues, but mainly because we still have a very high diesel consumption. Diesel consumption in trucks, in harvesting machines, and then this diesel consumption has carbon emissions. And it's very important, very high, the diesel consumption in this sector. So if we use biomethane from vinasse, we could replace almost 60% of the diesel consumption in the state of São Paulo, we could replace all the diesel consumption in the mills and even more in the state of São Paulo. So besides the more efficient use of vinasse, we could have the replacement of more fossil fuels, such diesel consumption in the state of São Paulo. Another thing, it's important to remember that even if Brazil produces oil and have refineries, we still import diesel oil. All our trucks and buses in the country consumes diesel. So the diesel consumption in the country is very high. So we import pure diesel in the country. So any new process replacing diesel oil is important not only because of carbon emissions, but also because of economic issues, because of our diesel imports. And I'm discussing that because it did happen in many other developing countries. All these studies related to biogas and biomethane in the state of São Paulo are part of this new project that we are working now. In the context of this center, this is a new research center that we have here at the University of São Paulo. Exactly in this building upstairs here, we have this research center on gas innovation. If you have time, you can go there. You just go up the stairs and you see a very nice part of the building. This is the research center on gas innovation. It's a research center working on gas. This means natural gas, biogas, biomethane, hydrogen, and we have around 100 new projects from different groups at USP. Okay, talking a little bit about water quality. It's important to discuss the synergies that we have with basic sanitation. In Brazil, as in several other developing countries, unfortunately, we still have lots of problems with basic sanitation. In many municipalities, in different areas of Brazil, in poor regions, we still do not have the adequate collection and disposal of urban waste, both solid and liquid waste. So we still have a strong environmental impact of this inadequate disposal. We do not have always good experience to share with you. We always also have problems to share with you. But we are learning a lot about that. And I would like to show you this experience in the state of Minas Gerais. You see, here is the lake of Furnas. Furnas is an important federal electric company in Brazil. And this is the lake where they produce hydroelectricity. And in this lake, we have several municipalities, around 30 small municipalities around the lake. And all these small municipalities don't have adequate landfills. So the disposal of the solid waste is very bad. And the consequence is that it was contaminating the lake of Furnas. So Furnas company started trying to solve this problem to guarantee the quality of the waters. Here you can see, this is Minas Gerais state in Brazil, southeast. Here is Furnas. Here you have the lake and the municipalities around the lake. And what they are doing, they are installing a small plant in one of these municipalities called the Boa Esperança, Good Hope. The name is emblematic. We always hope to be better. We are optimistic. So Good Hope municipality. With gasification of municipal solid waste. So they are installing with this company, Carbogas, with a Brazilian technology, 1 megawatt electric gasification plant for municipal solid waste. And then the idea is to use waste to energy so we can solve the problem of the inadequate disposal of waste. And things are working well, so we hope that we can have this process replicated in the other municipalities around the lake. It's the first project of this kind in Brazil. Regarding rural residues, we also have problems. Here you have the famous Iguaçu Falls in Paraná State, and also here we have the lake. And the problem that we also start to have is that small farmers around the lake was discharging the animal residues in the waters. And then the local utility, Itaipu, was worried about the contamination of the rivers and lakes. And they developed a project in this Ajuricaba Basin using the residues from the local farmers producing swine and cow, installing biodigestion plants, and using biogas for electricity production, and even biogas for cooking for the farmers. And more recently, they start testing biogas, producing biomethane for light and heavy vehicles. So this is another pilot project, important project in Brazil. Here you can see this is a special cooking stove for biogas. It's produced in Rio Grande do Sul, adapted because biogas is a medium heating value fuel, so you cannot use the same for natural gas, so you have to adapt. This one is produced in Rio Grande do Sul. Here you have the vehicle running with biomethane, and here you have the thermoelectric with biogas. Still talking about pollution, I showed you yesterday, just want to show you again, that besides carbon emissions, another very important positive impact from biofuels that we have in Brazil is the local pollution. Today we are lucky because it's raining, our pollution is reduced, but we still have lots of pollution in big cities like São Paulo. And you imagine, we have half of vehicles running with ethanol and all our gasoline blended with 27% ethanol. So you imagine if we did not have that, it should be worse. And this study published at Nature showed that exactly when we had the lower ethanol consumption in the flexi vehicles, we had a strong increase on particulate in the city of São Paulo, okay, because of the higher gasoline consumption. So besides carbon emissions avoided, we also have an important positive impact on the reduction of local pollutants like particulate matters when we use ethanol. Also, regarding air pollution, as it was mentioned here many times, we do not have anymore the burning of sugarcane. In 2017, last year, we had 98% of the sugarcane mills without burning, and this year is 100%. So we started with this legislation. We started with this legislation in 2006, and we even had more an upgrade in this legislation because we started to have it shorted. You see here initially it was forecasted to happen only in 2021, and it's happening now. So we had it happening before. And now all our sugar cane is harvested without burning with these harvesting machines. Also, in other states like Goiás and Mato Grosso, we have similar legislations starting now and with scenarios that should be eliminated by 2024, like in Mato Grosso do Sul. This has two advantages. Not first, the reduction on air pollution, because the burn of sugarcane has a lot of pollutant emissions, but also the amount of residues, which is going to be much higher, and the possibility of producing electricity much higher. Here you have some figures for Brazil in recent harvesting season. These are figures from UNICA, the Brazilian Union of Sugarcane. Here in 2 years ago, 2016, we had 378 sugarcane mills in Brazil. Almost half of it, 44%, produced electricity surplus, which means they produced all the energy they need and more surplus. And the rest of it, self-produces. And then you can see here, more or less, an illustration. You see here is the amount of electricity production. Here is the energy produced. So part of it, self-production for the self-consumption, part of it exported to the grid. In this harvesting season of more than 600 million tons. If we talk about installed capacity, we have in Brazil 1 gigawatt of production from sugarcane bagasse. Half of it is for self-consumption, more or less. Half of it is for electricity surplus to the grid. And now there is a big discussion in the country because we also have these pilot plants for second generation ethanol. The big discussion is what's the best use for the residues from sugarcane. Are you going to keep using it for electricity? Are you going to use it for second generation ethanol? Or what are the best economics and what are you going to do? So there are lots of studies under development in this area. And finally, talking about land use, as it was said yesterday, Brazil is the big cattle producer. Here you can see some figures for land use in Brazil. This is the total area of Brazil, 850 million hectares. Half of it, more or less, is Amazonia and rainforest. We have 350 arable land, and here you have different crops. And you see here, we have 168 grassland, 140 for cattle, and here you have ethanol, 8.6 million hectares. But this is to produce sugar and ethanol, more or less half and half. So if you could separate, we would have 4.3 million hectares for ethanol production. So as Cortez said yesterday, a very small amount of the Brazilian arable land. Here, we discussed yesterday deforestation. Here we have some figures. This is deforestation in Brazil. You see that we have this deforestation for agricultural expansion. This is mainly soybean. This is soybean. Deforestation for livestock expansion. So most of our deforestation is because of that. So it's not related to sugarcane. And here you can see a study that we did, our group did, together with the Secretary of State of São Paulo, having a look in a recent trend. During this period, from 2001 to 2008, we had a huge expansion of sugarcane in the state of São Paulo, occupying areas which were previously used for cattle. And then we were very worried that we could be pushing these cattle for other areas and making deforestation in Amazon with an indirect effect. So we followed this during this period, and what we realized is that the amount of the cattle heads was more or less the same. The area for pasture reduced a lot, from 10 to 7 million hectares in the state of São Paulo. But the density in heads of cattle per hectare increased from 1.28 to 1.56. So there was a trend for more intensive use. Of course, it's still extensive because, as Cortez said, these cows are very lonely, so it's too much area for one cow. But anyhow, we had this trend of a more intensive use. And if we do some scenarios for Brazil, thinking that these 170 million hectares using 170 million heads with a density of less than 1 cattle per hectare, if we could reach the same efficiency of São Paulo state, we could have a viability of 60 million hectares available for both biofuels and food. We just need to have a more efficient cattle raise in the country. And this is what, as Cortez said yesterday, the agroecological zoning of sugarcane did. This is the one for São Paulo, and then the more recent one for Brazil, showing the areas available for sugarcane plantation, and of course protecting Amazon, Pantanal, rainforest, Atlantic rainforest. Of course, all these issues are important because, and these are recent studies published in the Global Energy Assessment, where Eric Lasso and myself contributed. Here you can see the comparison of biofuels. That's why we always say that biofuels must be sustainable. If we don't have it produced in a sustainable way, we can have problems. Let's understand a little bit this complicated figure. Here we have fossil fuel, the average emission. Here you have different biofuels. Here we have the carbon emissions, and here we have the additional emissions from land use change. And you have different studies on each one. In average, you can see this is ethanol from corn. You have these studies from California Board, EPA, other NGOs. And this is a very controversial study from researchers searching it, because he considered that if we are going to make deforestation to plant biofuels, of course, if we are going to make deforestation to make biofuels plantation, we have a lot of carbon emissions. That's why we cannot do deforestation for biofuels plantation. When you come to ethanol from sugarcane, you can see lower values compared to corn ethanol. But also you have to do it in a sustainable way. Otherwise, you can have additional carbon emissions. You see here biodiesel from soy with very important emissions from land use because of soy expansion. And here other biofuels, ethanol from sugar beet from wheat, biodiesel from palm oil, rapeseed, sunflower. So if we do not do it in a sustainable way, of course we can have carbon emissions higher than fossil fuels. But if we do it in a sustainable way, we can have lower carbon emissions, lower than fossil fuels. Finally, just to let you know some recent studies with more detailed information that you can access and have a look. This is one of the recent theses at São Paulo School, here, at the University of São Paulo, discussing soil quality related to land use change for sugarcane expansion in Brazil. This is a master thesis comparing sugarcane, corn, and sorghum in a mill in Brazil, because we have now, as Cortez said, some mills in Mato Grosso do Sul, producing ethanol from sugarcane and corn and sorghum. And so this study compared this. And important to say that the corn ethanol production do not use fossil fuels. They use wood from planted forest in the boilers. So they do not have the same problem from other countries. Here is a recent study funded by FAPESP, also on bioenergy and sustainability, putting together lots of researchers from Brazil and abroad. Here you have the links. Also some studies I was personally involved with Professor Goldenberg and other researchers. This one on bioethanol from sugar, the Brazilian experience, in this Encyclopedia of Sustainability, Science and Technology. Recently, this is the second edition of it, released last year. Also, this Sustainable Bioenergy Production, where we did a chapter on the Brazilian experience. And more recently, this year, one of my PhD students doing exactly the sustainability indicators for sugarcane mills in the state of São Paulo. It was this was the first PhD thesis in this new program on bioenergy that we have, and I just talked to you about. Finally, I included two slides trying to address some discussions we had yesterday, showing what we have changed in alcohol cars, vehicles, and the flexi vehicles, so we can have they running with pure ethanol. So you can see we have a lot of change in the vehicles to run with pure ethanol. This is from Volkswagen. But this is the one I want to show you because we discussed this yesterday. This is provided by ANFAVEA, which is the federal union of manufacturers of engines in Brazil. And they show that depending on the ethanol content in the fuel, you must have some adaptations. So the green one, you don't need any adaptation. The red one, you need adaptation. So up to 5% of ethanol content in the fuel, they inform that we don't need any change. You just put it in the engine and there is no problem. Up to 10%, if you have fuel injection, or not so much old cars, you also can have without any change. And depending if you increase up to 25, 85, or more than 85, then you have to increase the change in the vehicles. Okay? Okay, obrigado. Thank you. I talked a lot, but we have some time. 10 minutes. We have 10 minutes, not so much for questions, but
Good morning, Jairo from Colombia.
Where? Okay.
Thank you, Professor Suani, for the lecture. I would like to know regarding to the municipality solid waste plant in Minas Gerais. What is the process, the recycling process? It is done in the source? Is a source separation, or is done in the plant?
Well, in Brazil, we do not have the recycling in the households because we do not have the collection with recycling. So what we have is that in several municipalities, we have local workers working with the recycling. So we have several cooperatives, and then we have the workers doing the recycling. So in all these plants, is a good question because I forgot to talk about that. In all these plants, and now we have a new legislation make it mandatory. We have to include recycling, and then all these plants have these cooperatives of workers doing the local recycling. Okay?
Hi, Professor Suani. I'm Daniel from Brazil. I would like to know your opinion about the Renova Bio project program, the national policy for biofuels, especially for the opportunities for biomethane, not related to the sugarcane industry.
Yes. This program, Renova Bio, approved last year and already signed by federal government, is considered a very important program to increase and to incentivize the efficient biofuels. It was mainly driven by the sugar sector, sugar alcohol sector, thinking about ethanol, but it's, the objective is all biofuels. So it includes biogas, it includes biomethane, okay? And even because, as you said, we can have biomethane from different other sources, animal residues, municipal solid waste, and not only vinasse. I think it's a good opportunity. I think we have a challenge because the whole evaluation is based on life cycle assessment. And life cycle assessment is something not so much spread in the country. It's more or less concentrated in the universities and in the researchers area. So I think we have to do a lot of work to make people understand what is life cycle assessment and how it works. So Embrapa, the federal, one of the federal institutions, is working hard to develop this methodology and trying to disseminate this information. I just heard that this August 16, I think, 16 August, next week, there's going to be a workshop here in São Bernardo do Campo where they are going to discuss, it's an open workshop, this methodology and to listen from people. So I think it's going to be a good opportunity, but we still have to work a lot to make people understand and to make people do it in the right way.
Thank you for your presentation. I'm Victor from University of Malaysia. I just want to give, yes, I'm Victor. I just want to give a piece of information. Then the second one is a question, actually. You know, when you were presenting, and you said Nigeria imports crude oil because they don't have refinery. Actually, Nigeria has 4 functional refineries, but they are not producing to the capacity. So, to meet the local demand. So because of that, so they have to import refined products to supplement for what the local refinery is producing.
I didn't know that. Thank you very much.
Okay, yeah. Okay, the second question is, you said one of the, a kind of proportion for replacements of biodiesel is using biogas. Now I want to, there are issues with biogas production. It's not, in terms of production rates, it's not as fast as production of biodiesel. So what is the viability of, in the long term, what is the viability of achieving such vision?
First, thank you for the information. I didn't know that. Have to update my files. Second, in fact, at least in Brazil, we have still lots of challenges. The technology is quite well known. People know how to. I am just a chemical engineer, but people like Simões and the mechanical engineers, they do know how to make engines change from diesel to biomethane or natural gas. So this is not a problem. The problem is that, at least in Brazil, we have a very conservative behavior of the engine manufacturers. So even manufacturers that have this type of engines in Europe, like Volvo and, I don't know, Scania, they don't want to do it in Brazil. Don't ask me why. Ask them why. I don't know. So we have lots of people working on that. The Secretary of Energy of the state of São Paulo, one of our colleagues is working there, Professor Negro, a very senior professor in this area of engines, has been working hard. But in general, they say, we need a market. So it's a problem of chicken and egg. So we need a market. We still do not have the biomethane, so why do you have a market? So it's a big discussion. But we hope we can solve this in the near future. But we still have this problem. Anything is so easy. Sorry.
Professor,
Okay.
hello.
Hello.
Thank you very much for the presentation. My question is regarding the bioeconomy and Brazil, because much has been discussed that the bioeconomy can substitute or complement the fossil fuel economy in a more decentralized way, and producing not only fuels but also chemicals and materials. Do you think this in a long-term future will be a reality for Brazil, considering these smaller farmers, differently from what happened with biodiesel and sugarcane with big companies, especially the sugarcane now that big companies are buying the small mills? So do you think this could be a reality for Brazil?
I hope so. I think that Eric Lasso is going to talk a little bit about that, including bioenergy and carbon capture and storage. I think this is a good opportunity for developing countries in general. I didn't have time to go into more details for different countries in Latin America, but I have in the presentation, and you will have it. I think another issue that important experience that we have in Brazil, and the people in general do not know about it, and Monica knows that better than me, she's my doctoral student in this area, is the use of charcoal. In Brazil, we do not use, charcoal in general is seen as being used in households in efficient way, like firewood. But in Brazil, as you know, probably know, we use charcoal in the iron and steel sector. So a large part of our iron and steel sector do not use mineral coal, use charcoal with good advantages on emissions. So, and this is something that in general people do not know in other countries. I was recently in Copenhagen in the European Biomass Conference, and I saw some students from European countries saying, oh, we are going to replace coal by charcoal, and doing lots of studies in economics and so on, seeing how they could replace. And when I discussed it with them and I told them that we do that in Brazil, they asked, oh, you are just starting. I said, no, we do it for 50 years or so, or something like that. If you see our energy balance, you see that for a long time, the iron steel sector already uses charcoal from planted wood. So I think it's a good opportunity. I really agree.
Thank you.
I think we don't have time. One last, because Professor Simões is already watching me. Okay, the last one, please.
Okay, this one is regarding to the last slide that you showed. Colombia from this year is using 10% of ethanol in gasoline. Well, I don't know what is the topography of Brazil, but for example, in Colombia, when it start the natural gas conversion, sometimes the performance of the car was pretty different at sea level compared to Bogota at 3,000 meters. So
I can imagine. I was in Bogota and I almost died because too high. No, just kidding. No. I
Yes.
survived very well.
So the question is, that slide that you show is taking account the height of the how to say that?
Yes. Well, we don't have this problem in Brazil. We do not have so high
Okay.
altitude. We have in São Paulo here, we have Campos do Jordão, it is 800. Now we are 800, and Campos do Jordão is 1,000. So this is the maximum we have. So, but of course, you have to take care. Just to try to answer you, I had a student here from Nepal, and then he was evaluating based on this study that we do now, he was evaluating the perspectives of biogas in Nepal to replace firewood, the traditional biomass. And then he realized, because also Nepal, they have very high altitudes. I never been there, but I learned it with him. You cannot have biodigesters because the temperature is quite low, it's cold. So he had to divide more or less Nepal in areas. The lower altitudes, they put the scenarios of biodigester. The higher altitude, they try to use LPG. So this is a problem. We do not have this in Brazil, but I understand it's a problem. I have been in Bogota a couple of years ago. I went there to give some speech, and the first day I just stayed in a hotel, sleeping, trying to recover from the altitude. But everything ran well.
Thank you.
Okay. I think we are on time. Thank you very much. I'll be around for the coffee, and after the coffee break, we'll come back to Professor Eric Larsson.